All right, guys, so we're going to go over the review. This is your chance to ask questions, kind of see what we're doing. So we went 6 through, was it 70 even?
Yes.
90. 90.
Oh, yeah. There are a lot of them, but some of them were just like, all right?
Yeah.
What's number 6 say, Haley?
7 times 7 times 7.
All right, exponential form.
Okay, so 7 to the 3rd, right?
Yep.
All right, we did all right with those. What's 8 say, Lucas?
8 says k times k times k times k.
So it's k to the 4th. You feel pretty good about those?
Yeah.
All right, so how many of those did they give you?
They give you 10.
12, 10, 12. All right, let's just do 10 and 12. 10. What's 10 say, Trenton? Book's open for everybody. Let's make sure we get
Negative 2 times negative 2 times
negative 2 to negative 2. Okay, talkers over there. I'm sorry, because of the mic, I got to have you quiet. So, it is important with this one. There are 2 ways that I would accept it, okay? That is okay, okay? Because there's 2 of each of them. This is another way that is acceptable, though. Because this is saying 2 of these, 2 of these. This is saying 2 of the whole thing. So do you see how there would be 2 in each case?
Yeah.
This is probably the one you're going to want to realize. But you're going to want to realize, like, when you can multiply 4 times 5, or multiply 5 times 4, or 5 times 2 times 2. If you can realize these look different, that will help you later on when you start to cross things out and simplify them, okay? All right, Carson, what's number 12 look like, sir?
6 times x times x.
6 times x times x. So how'd you write it, Carson?
What did you do? 6 to the first power x to the second.
All right, 6 to the first, x to the second. That one would be okay to write like that, because it's not saying 6 squared and x squared. It's just saying x squared and 6 is there. Because you have to do exponents before you do multiplication, right? So that would be okay. Now I have a question. What about this? What do you think, Crew? Is that okay to write it like that? She says yes. What do you say, Haley? You don't know, Michaela?
Yes.
Yes?
No, because isn't it 6 times x?
Well, they're saying 6x twice. So you'd have 6x,
Exponents need to have
6x. This is only saying 1 at 6. Do you see that?
6 times x to the second.
Yeah. Or if there's nothing written there, we understand that is multiplication, right, Taylor?
Yeah.
If you want to slide left or right, you can, Taylor. So this, no good. Okay? Because that means everything. So when the parentheses is around it, that does change what it's squaring, what it's doing duplicate of. All right, Christine, 14. What does it say?
It says you have to simplify and put 5 to the 4th.
Okay. What is it now? 5 to the 4th?
5 to the 4th power.
5 to the 4th, so 625?
Yep, yeah.
Because it meant 5 times 5 times 5 times 5. All right, very good. All right. Summer, what does 16 say?
Negative 1.
Negative 1. Is that the answer, or?
Negative 1 to the 9.
That is the answer. Negative 1, like this, to the 9th? No.
Negative 1 to the 9th power.
All right. So, remember, if we have a odd exponent, we know that the answer, if it's negative over here, will be negative, right? If it was like negative 1 to the 8th power, would it be positive 1? Why? Can somebody tell me?
Even to the 8th power or something.
Yeah, so negative 1 times negative 1, negative 1 times negative 1, negative 1 times negative 1. They all pair up, and then you get them to all positives that second time, and then we're just multiplying like normal, right? Whereas with this one, they all have a match except 1. Well, then that leaves 1 negative left, right? Go to explanation, Lucas. 18 here. Michaela, what's number 18 say, ma'am?
Negative 3.
To the first power. So what does that one become? Did you find your phone? I'm sorry, go ahead, Michaela.
Negative 3.
Negative 3 is your answer. What happens if it's to the 0 power?
1.
1. Anytime something's to 0 power, even if it's a negative, Negative 3 to the 0, still just 1. Okay? Anything to the 1 or the 0 power is 1. Because like this is saying take negative 3 one time. This is saying take negative 3 0 times. Well, if there's nothing left, there's always understood to be a 1 there. Okay? All right, 20. Go ahead for us, Natalie.
Negative 3 to the third.
Negative 3 to the third. So just looking at, is our answer going to be positive or negative?
Negative.
Negative, because we have an odd number. And what does it end up being? Negative?
27.
Wonderful. Good job. Negative 27. All right, let's do 22 here. Natalie, stay with me for that one.
15 to the first.
15 to the first. All right, so 15 to the first. What is that?
15.
15. Because it says take 15 one time. 15, pretty easy. All right, 24 then. Corey.
10 to the fifth power.
10 to the fifth. All right, so what does it ask us to do there? Simplify, so 10 to the fifth is? What was it? 100,000. Now, the easy cheat, if it's 10 to a power, the power tells you how many zeros, right? That's just a cheat that we figured out. We can see a pattern there. All right, we can do all the multiplication, but that's a quick cheat. All right, Tori, stay with me for 25 or 26, please. 5 to the negative third. Ooh, now we have negative exponents. What does that mean we do?
I put it over 1.
Ah. You did it like that? Okay.
No,
The other way. So, or is it negative third still? Remember, when it goes across the division bar,
Positive.
the sign of the exponent changes. Okay? Because this is saying like division by negative. No, that's saying division by the third, 5 to the third power. That's saying like division by 5 to the third power. Okay, so then what did you get for your final answer?
1 over 125.
1 over 125. So the first step is get the exponent positive. Then we can do all our work, because that means 5 to the third. You guys know how to do that, right? Taking it across that division line takes it from negative to positive. So if I wanted to, I could even have 10 to the fifth. Would that work? Could I do that? Does it make any sense to do that? Not really, but taking it across there shows me to get it back, I would have to take it back across and it'd be the same thing, right? You see it? So while that one doesn't really make a lot of sense because we want to get rid of the negative so we can get it simplified, later on you'll see, oh, that negative exponent, we do move it around. All right, 28, Connor.
11 to the negative first power.
So negative first, so what'd you get?
11.
No, I'm sorry.
1.
No, I'm sorry. What's the first thing we got to do, Connor?
Find the reciprocal.
Find the reciprocal. We got the negative. We want to get rid of it. So what are we going to have when we find the reciprocal? We're going to have
1 over negative 1.
when we move it from above the fraction bar to below, the negative and the exponent changes. It switches signs. Okay, so we do that. Then we have 1 over 11 to the first, so then we get 1/11. Okay, so that's why your answer wasn't quite there. First thing we do, get the exponent positive, then do what it says. When the exponent's positive, and we get 1/11.
Wait, so if we put 11 is wrong?
If you put 11, it is not right because it is 1/11 because you had to get rid of that negative exponent. Okay, it is 1/11. And this is why we want to go over them before we take the test, so that's a good thing. Connor, stick with me for 30. Go ahead, sir.
100 to the 0 power.
100 to the 0 power is what, Connor? 1. 4,338 to the 0 power is?
4,335.
All right. So now I forget what number we did. We did 30. So 32. We move on. Onward and upward to crew. 32, Drew, I'm sorry, I said 31, didn't I?
9 minus 7 to the negative third.
9 minus 7 to the negative third, like that?
9 minus 7 to the third.
Like that?
No,
She said it just fine. Like that?
Yeah.
All right, so what do we do first, crew?
I subtracted 9 minus 7. Got 2.
To the negative third, so then what does that equal?
And I took it over 1. And then 1 over 2 thirds.
And that equals?
I got 1/8.
That's what we were looking for. All right, that's what we were looking for. How are we doing now, Connor? Did you do good till you got down here? Did you have just 8 as your answer? Yep. So don't forget taking that down below. And I don't do this to pick on you, but I do it to harp on you. So hopefully, hey, maybe we can remember that for the test and stick with us for a while. 34. Go ahead, crew.
It's 7 minus 10 to the 0 power.
Like this?
Yeah.
Woohoo! I got it right the first time. All right. What's 7 minus 10 to the minus 10?
Yeah.
Yeah.
Negative 3.
Negative 3 to the 0 is?
Yeah.
1. All right. We did pretty good there. We did pretty good there. All right. 36, Taylor.
36, it says 3 to the negative second times 2 to the negative third times 9 to the 0 power.
Like that. And what does it ask us to do?
It asks us to simplify, so you have to do 3, we could do 1 over 3 times 3.
Okay. All right. So 1 over 3 times 3, because that's 3 to the second. So 1/9.
And then you do times 1 times 3, no, times 2 times 2 times 2.
Okay.
And then you have to do times 9 to the 0 power is 1.
Okay. So with the 1, do we really even need the 1 there? Because anything times 1 is its. So, yes.
Like this. I didn't write all those tips that you did.
No, I'm just kind of writing them so you can kind of see the progression. It looks like you got the same answer though. So she said, get it to the bottom. So then we have positive exponents, right, Connor? All right. Then 3 times 3. That's what 3 squared means. 2 times 2 times 2. That's what 2 to the cube. So what do I need to do in my last step here to finish it up, Taylor?
Take 1 over 9 times 1 over 8.
All right, and we get 1 over 72. Yep. Well done, well done, well done. All right, so we did exponents first, then we did multiplication. PEMDAS. Remember, if you have the PEMDAS chart that you still had at the beginning of the year, with all the extra things that you wrote on it, that's fine. I tell you to put them there. Make one big math cheat sheet, and you'll find that as you use it and use it and use it, you're going to see those enough that you'll remember it. All right, Taylor, let's go with 38. You did such a good job on 36.
We're on to a new one. Then write the product or quotient as 1 power.
Okay.
So it's 4 to the second times 4 to the fifth, and your answer is going to be 4 to the 7th.
Okay.
Just add them.
When we're multiplying numbers with the exponents, if the base is the same, we can just add the exponents, right? All right, very good. Gavin, what about 40?
D times P to the third.
D.
P.
Okay, what do I do? No, what does it say? P times P to the third? Okay, I'm sorry. All right, P times P to the third. So what do we do, Gavin?
P to the fourth.
P to the fourth, because there's understood P to the first, right? So then you add, since they're multiplying. No. The 4, Bruce. All right, since they're multiplying numbers with the same base, we add the exponents, we get P to the fourth. Go ahead, Gavin, 42.
6 to the second times 3 to the second.
6 to the second times 3 to the second. Can we just add exponents here, Gavin?
No.
Why not, Gavin?
Because
Base is not the same, therefore we can't do it. We could do 36 times 9 and get that big number. 270 and 54 is 224. That's fine, but I don't know if they asked us to do that or not. So, since the bases weren't the same, we just can't add the exponents, okay? That's the important thing. Now, that was 36, do whatever.
I had 18 to the second power.
Right here. Good, okay. Good, that's what I was hoping to see. All right, 44, go ahead. Daniel, nice and loud, sir. Remember, I'm old.
8 to the 5th power over
Over 8 to the second power. All right, when we're doing division, what do we do with the exponents, Daniel? Subtract them, so you get 8 to the third. All right, 8 to the third. Another way people think, if I brought that up, I could say 8 times 8 to the negative second. Do you see how that's subtraction then? Okay? Because I could move this up and change it, but we'll just stick with saying if it's division, we can do that. 46, Daniel. Into the seventh over into the second. Okay? And that ends up being what, sir? M to the fifth. All right, very good, very good. And 48, then, Miss Christine.
Okay, it's 4 to the negative 5th power over 4 to the negative 5th power.
Ooh. Minus a negative, so what did we get here?
So, isn't it 4 to the 0?
4 to the 0, which would be
1.
1. Now I want to show you something else real quick. 8 over 8 is a fancy.
1.
Are these exactly the same thing over exactly the same thing?
Yeah.
So we can realize if you have exactly the same thing over exactly the same thing, it is a fancy 1. Way to work it out with negative 5 minus a negative 5, 4 to the 0 and 1. I'm just showing you a way to double check what we did there. So very good job, Christine. That was probably one of the trickiest ones in that section. 50. Haley.
5 to 0 times 5 to the 3rd.
All right, that gets us 5 to the what? Third. Thank you. 5 to the third. Very good, very good. All right, 52, Haley.
K to the 4th divided by K to the 4th.
What's our answer?
I got 1.
Got 1, because K to the 0, and that equals 1. Or, like we learned earlier, exact same on top, exact same on bottom. That's 1, right? All right, 54. Summer?
1.6 times 10 to the negative 3rd power.
Times 10 to the negative 3rd. Okay, now it's important when we do scientific notation. All right? One place left of the decimal for scientific notation. That was the thing that I noticed was most messed up on the back when I'm grading these with the review. When you're making it into scientific notation, this goes where there's one number that's not a 0 left of the decimal. That's important. Get it to one number left of the decimal. Okay? So then they're asking us, Summer, how to switch it into regular number, standard form. What do I do, Summer?
So there's negative 3. That's negative 3.
Negative 3. Okay, that's important. It does change things. So what do I do then, Summer?
0.00162.
There's a 2 there. Okay. 1, 2, 3. Fill in with zeros. And we have it. Negative 3 tells us to move left. Think about negative, it's going to be a smaller number. Is that a smaller number? Yes. If it's positive, it's going to be a bigger number. Okay. The exponent tells us how many places we're going to move it. The negative tells left. Positive tells right. Good job, Summer. And you did so good there. Would you stick with us for 56? What does it say, madam?
9.1 times 10 to the negative 5th power.
You just like little numbers, don't you? All right, what's this one end up being?
0.0000091.
Okay, because you went 1, 2, 3, 4, 5 spots. That means there's 4 zeros there. Don't forget, where we end, that's our new decimal spot. Okay? How are we doing on the kind of everybody, how we doing on the scientific notation? Turn it into standard form. Just kind of give me a nod, give me a heads up, give me a, Mr. Palm. Okay? So, 5 spots, because that's what's in the exponent. And then negative means to the left. Okay? And there we go. We get 0.000091. Good job. Okay? Oh, you just put 3 zeros in front of it. It's for moving the decimal times, not 3 zeros. Okay? Okay. What was your? Okay, when it's negative, remember, it's going to make a smaller number, so we move it to the left. Okay? That's the way you can think of it. All right, 58. Good job, Summer. Lucas, 58 for you, sir.
58 is 0.04.
Okay, and they want it in scientific notation?
Yes.
What'd you get, sir?
I got 0.4 times 10 to the negative first.
1, 2. 1 0 that is 1 non-zero that has to be left of the decimal, Lucas. Okay. Oh, but when you did the others, let's look at them. Okay. That's why DCF should go in one more place, and that changes that one more. This one, you did right. This one is that 56.4. Decimal should be right there. One place that is one that's non-zero left of it, okay, Lucas? One that's non-zero left of it. So this one should be 4.0 if you want, or 4 times 10 to the negative second. Because I had to move this 1, 2 spots, so that's where I get the negative 2 from, okay? So 60, Lucas.
7.3. Wait, no, it's 73 million. 73 million.
73.
That's the number. And the scientific notation is 7.3 to the 10. Times 10 to the 7th power.
Okay. Decimals here, so 1, 2, 3, 4, 5, 6, 7. 7.3 times 10 to the 7th. Very good. So again, this was a big number, so we know it's a positive. That was a small number, less than 1, so we know it's a negative number there. That's the way we can think about those. All right, Trenton, number 62.
What if it's 56? It's a big number. It's 56, 400, 0, 0, 0, 0, 0, 0.
Is that it?
No, there's another. One more.
One more 7 3 zeros, like that?
Yep.
All right. Now, we know the decimals here. That becomes important. So what'd you get, Trenton?
Would it be 56.4?
It wouldn't. We want it to be right here.
Yeah, that's what I thought. So then it would be 10. It would be 10 to
5.64 times 10 to the 10th.
Yep.
And do you see how when we do that, Lucas, then? There's just one left of it. That's what you're looking for. One number left of it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Nice job. 64, Trenton.
It says find the 2 square roots of each number at
16. So the 2 square roots of 16 are?
4. What's 4?
One's 4. The other one's negative 4, right? Because negative 4 times negative 4 is 16. All right, Carson, 66. What's about 676? Okay, so what's that?
26 and negative 26.
Ah, nice job. And that's one where I don't mind if we use a calculator to get, because otherwise that's really hard to figure out. All right, 68. Carson. I should have closed the door, but I said that. All right, what do you have, sir?
It's 100 over 20, but there's over 100.
100 over 20, and just on the top?
Yeah.
Okay, so just on the top, so what do we do?
Minus square root of 100.
Square root of 100 is?
Okay.
So 10 over 20 is then? 1/2 is our answer. All right, 1/2 is our answer. All right, 70 then. Tori.
I did not know how to do this. I kind of forgot.
Okay. So, all right, Lucas is willing to help you out. What is it, Lucas?
We can do 500 times 500.
What does it look like? What does it start with?
Yeah, we can do them back to form the same thing.
Okay.
That's one time.
Oh, a square.
It's like 500.
All right, what do we know about a square, Tori?
Got 4 sides.
There's 4 sides, and all the sides are equal. So we have the same thing times the same thing. So we do take, to get the sides, we would take x times x, right? And that would equal 500. Do you agree, Tori?
Yep.
All right. So what's x times x? X to the first would be... Does that make sense? Bases are the same. So now we're trying to get it down to where it's 1x. How can we get x squared to be 1x? What do I have to do? I have to take the... It is the inverse of this, but it's the square root. Because the square root of x squared is x, because it'd be saying like what times what makes x. So if we did it to one side, what do we have to do to the other side, Tori? Okay. And the square root of 500, can somebody help us out?
22.3.
22.3. Okay. So that means each side is 22.3. 22.3. You'll notice when they say that it's a square, we can know that both sides are the same, Tori, and it'll work out. If it's a rectangle, we can't probably use this process because both sides are not the same. Does that help you out, Tori? All right. Are you willing to try 72 with me then? Okay, what does 72 say, madam? 1,750?
No, that's 71. 72 is named an integer. Name the integer. And I think it.
Oh, okay. So, square root of 82. So, they want to know, remember how we could kind of guesstimate and figure out in our head what it is? So, what'd you figure out, sis?
7 times 8. No, 10 times 81. And 10 times 10.
So, the answer is between 9 and 10. What is the answer likely? What guess did you make at the answer then, Tori? 9.1, and that would be definitely close enough. It's probably going to be like 9.07 or something, or 8. But yes, that would definitely be close enough for me. All right, Natalie, 74.
See if it's rational, irrational, or not a real number.
What am I dealing with here?
122 square root.
Square root of 122? All right, is there a perfect square root for 122?
No.
No. If it's not, what group does that put it into?
Irrational.
Irrational. If there's not a perfect square root, it's irrational. Very good. All right.
Would it also be real?
It would also be a real number too, but do they ask you to give all the names of it?
No, it just says name if it's. State if the number is rational, irrational, or not a real number.
Okay, that's important. We'll let you have your book open to the page with that chart on it. Okay, so I think that's I forget what page it is.
For irrational, they can't be divided down anymore.
The reason why they're irrational is when we do this, it'll be 11.1247473. It's a decimal that goes on and on and on forever and never ends. That's why if there's not a perfect square,
It's
it's
called
irrational.
195.
195, Lucas says that's a page that we'll all be able to open to before we get the test. Okay? So, 76, Natalie, would you stay with me on that one?
It's the negative outside of the square root, and then 5 inside the square root.
Okay. So, does 5 have a perfect square? No. It's not negative, so what would this one be? And it is important to read the directions, because if it says just name it as rational or irrational or not a real number, then you just have to write 1. If it says name them all,
How do you know if it's real or not?
how do you know if it's real or not? The only ones that are not a real number, there's 2 ways to have not a real number. if the negative is inside the square root. Because there's no way I can take the same number times the same number and get a negative, right? Because a negative times a negative is always a positive. The other way is 5 divided by 0. Oh, whoops. Because no matter what I put up there, 0 times anything is 0. I'm never going to get an answer, right? So these are the two ways to have not a real number. Not real. Not real. That's the only two ways you have not a real number. Okay? Because I can't divide by 0, because no matter what I do, Haley, even if I put 7,000 times 0 is 0, I get no closer to finishing the problem, right? I can't finish it. Here, I can't have any two numbers that are the same to get a negative answer. Okay? Those are the only two ways to get a not real number. So if you're looking at that chart on page, what was it again?
195.
195. Let's go there real quick. I think that'd be a good thing to do. Keep this one marked. So if you're on 195, so the only numbers that fall outside of this box are numbers like those. Those are example numbers, all right? Not just negative square root of negative 17. Square root of negative 4 would be also not a real number. Because there's no way 2 times 2 is 4. Negative 2 times negative 2, well, that's 4. Okay? So not real numbers, they are outside of this box. Everything else is a real number and inside this box. So if we get 2 and they say, give me all the names, they're expecting natural numbers, whole numbers, integers, rational numbers. The natural numbers, 1, 2, 3, 4, on to infinity, positive numbers. Okay? Whole numbers, 0, 1, 2, 3, 4, on to infinity, positive numbers. Okay? So the only difference between natural numbers and whole numbers include 0. Natural numbers don't. Then we get integers. Well, integers include all the natural numbers, but then they also include all the negatives of those as well, right? And then rationals, well, there's decimals and fractions in there, all right, that either repeat or terminate. These irrational ones, they don't terminate. They go on and on forever, okay? Pi is an example, and then the square root where there's not a perfect square, okay? So that page we'll be able to use. 78 then. Let's roll on. We just had Natalie, so Michaela. 78, Michaela.
Seven over 0.
7 over 0. So what is that one, madam?
Rational.
No, I'm sorry, it is not. Can we divide by 0? Division by 0. So when 0's in the denominator, it's not a real number. Okay? Not real. I don't know why I put a T there. Now here's this tricky part. Or 0 divided by 5. Well, I can do that. 0. And I get it. All right? So 0 divided by 5. If I have 0 things, can I divide them into 5 groups? Sure. Everybody gets it nothing. Right? But, well, that's not what I want to do. If I have 7 things, can I divide them into 0 groups? There's no way I can get rid of them. I can't break 7 things into 0 groups because that means they go nowhere. There's no way I can do that. There would be one group, but I want them into 0 groups. So, since I want them into 0 groups, that means I got to have nothing. So that's not a real number. Okay? All right? 80. All right. Does that make sense, Michaela?
Yeah.
Okay, awesome. What is 80? What do you have for 80, Michaela?
A equals 6, B equals 8, and C.
It says if A equals 6 and B equals 8, then that's 5.
Oh, are these legs of a triangle? Okay, so tell me what to set up there, Michaela.
A to the 2nd power plus B to the 2nd power.
Equals C to the 2nd power?
Yes.
So 64 plus 36 equals 100 equals C squared. What do I do now, Michaela?
Square root.
All right.
100 and square root.
Square root of both sides, so C equals 10?
Yep.
Very well done, very well done. All right, 82, crew. Oh, perfect, it's gonna work out great.
If you find the length of the hypotenuse of a right triangle with the leg lengths of 10 inches to the nearest turn.
10 and what?
With the leg lengths of 10 inches to the nearest turn. It's a word problem.
So both legs are 10 inches?
Yeah.
Okay. Is that what we read it as and took it as, guys?
Yeah.
Okay, so how do I set that up then? What do I do, crew?
I do 10 squared plus 10 squared. Yeah, that's what I do.
And it's going to equal C squared, all right?
Yeah.
So then I have a hundo and a hundo. So 2 hundo equals C squared. And what'd you do then, crew?
14.1.
All right, because you took the square root of each. 14.1. She sound like she's doing pretty good, guys? All right, Conrad, 84. What do I do? Ooh, a distance one, okay.
Square root.
Oh, all right, he's doing a film Majagi in. All right, can I write these two up here? What are the two? They're 8 to the 0 and 0 to the 0, 8. So 8 to the 0.
Oh no.
Oh, I thought I was going to have to lose my temper. I kind of did too. All right, like that. That's kind of what you got going on there, Chip. All right, so now, is that where we use x1 minus x2
Yeah.
squared? Is it plus or is it minus?
It's plus.
Plus y1 minus y2 squared, right? When we do all that, it'll give us our distance. Okay, so the x's are referring to the x in each one, right? So what did you do to set this up then, Connor?
So I did 8 minus 0.
Okay,
Squared plus 0 is
okay, so 8 minus 0 would be 8. 8 squared is 64. Would you agree?
Yeah.
0 minus 8 is negative 8. Negative 8 squared is 64.
128.
Then did you get 128?
And then you, yeah. And then you get.
Okay, and what'd you get there, Connor? Get Taylor help you out? Looks like she got it already.
11.3.
11.3. 144 would be 12. 121 would be that. 11.3. Okay, very good, very good. Distance formula. If that ends up being on your PEMBAS chart written down, distance formula for 2 points, you can do that. That's no problem. All right, 86. Daniel. All right, 86. 5 minus negative 4. Okay, and is that in the first parentheses squared? All right, what's in the second parentheses? Negative 2 minus 10. And that's squared. All right. So that's like adding them. So 9 squared plus negative 12 squared? Is that what you came up with, Daniel? Okay. So 81 plus 144. 5, 12, 225. 15, Daniel? Oh. All right. Well done. Well done. All right. So, Tori, I see a questioning look. Yes, ma'am? Okay, so what happened? Okay, so where's the work at? Here's everything. It looks like you subtracted 2. That's what my thought is. So you may have just hit, because addition and subtraction are right next to each other on the phone. So it looks like you just subtracted instead of added, and that would have changed the answer. You see that, how that happened? So I don't think it's anything. It was just an oopsie daisy that happened. Yeah, but number 88. Okay.
12, 5, and 13.
12, 5, 13. How do I check that out, Gavin? Because I know that 13 is my hypotenuse, so go ahead. You want to see Taylor do one, then you can do 90?
Squared,
What's that?
12 squared.
Okay, I like 12 squared.
Plus 5 squared.
Plus 5 squared. Equals 13 squared, right? So that's 169. 25, 144. I add those together, 5. Oh, whoops. 9.
So it would be yes.
If they equal each other, it would be yes.
What did you add together? You
You
add
69 and then
13 squared is 169. 5 squared is 25. 12 squared is 144. Sorry, I got going fast. When I added those two together, I got 169. And if the numbers are the same, yes, it's equal. It works out nice and dandy and good. All right, then 90 here, Taylor.
And you have, this is a word problem. It's going to be 7.5 times 7.5. And then you're going to do 10 times 10, which is 100. And then you do equals 12.5. I think that's right. And then you do 12.5 times 12.5.
Okay, so I could have done it like this, just in case what she's saying is throwing you off. Because isn't this and that, are those lines the same thing, Haley? Do you see that? Okay, very good. All right, so when you did all that, what did you get, Taylor? 7.5 squared is?
56.25.
25. 7 times 7 is 49, so that makes sense. That's 100. So 156.25 when I add those two together.
Yep. And that's what
And that's 100 and
12.5 is too. So it's yes. And it says explain why, and I just said yes because it's equal.
yes, because it's equal. Well, because then Pythagorean's theorem holds true, and we're there. All right. So you've got 45 minutes to take this test. I think that should be enough because some of these are easy. You may open to page 195. All right. You may have those. When you turn in your test, please turn in your review, unless you want to give me your review when you start taking the test. Okay. There are 25 of these, but some of them, like you saw earlier, are very easy. Okay, you can have your PEMDAS charts out if you so choose. Those are always available and open to be out. Don't forget where your review is. Even if you wrote down answers from when we were working together, Kevin, that's fine. I just need a finished copy of that so I can give you the points. Jacob, you can start working
Close.
on yours on your end.
Thank you.
Bruce, you can start working on yours on your end. I'm stopping the video.